Hello, this video is on ions and ionic bonding. So first let's talk about bonding. We have two different types of bonding. One is called covalent bonding, and the other is called ionic bonding. And someday you may learn about metallic bonding and other types. But basically what's happening here is you have two atoms. Let's say these are our atoms, and they're being drawn together to make a compound. Sometimes we call compound molecules, depending on what atoms we're doing. So it's the way that these are brought together to make a compound. Bonding is based on the octet rule, meaning that we have 8 electrons in each ring of our atom. So if you remember, we have our nucleus, and then we have rings that go around our atom. And in most shells, except for the first one, we have 8 electrons, right? So that's based on the octet rule. So most atoms do not have full orbitals, right? So this orbital wants 2 electrons to be happy. This orbital wants 8 to be happy. And as we go out, they also want 8. So our goal when we're talking here today is that we want to make orbitals happy. The atom wants to be happy because it wants full orbitals of electrons. So we do have some atoms that are already happy. So if you remember talking about the periodic table, these atoms over here, these atoms of these elements, helium, neon, argon, krypton, xenon, and radon, they are stable. Those elements do not like to bond with other elements because they have full orbitals already. So a few elements just want 2 electrons. So those elements are hydrogen, helium, lithium, and beryllium. That's because they have they have a low number of electrons, and so they just want this first orbital filled. So today we're going to focus on ionic bonding. So let's start by talking about what an ion is. So an ion is a charged atom, or let's say a charged particle, because it's not really an atom anymore. So an ion is a charged particle. And what happens is we have ions of metals and nonmetals that like to come together. And in ionic bonding, we have electrons that are transferred from one ion to another. And generally, you have the metal donating the electrons to the nonmetal. And then ions are attracted to each other because of a difference in charge. So one ion will be negative and another will be positive. And if you remember talking about negatives and positives, they like to come together, right? So that's what's going to hold our ionic compounds together. Okay, so let's take a look. Let's draw some ions and talk about why they're ions. So let's start by looking at lithium. Let's draw a lithium atom over here. So lithium atom, if we remember from last video, lithium has a 3 as an atomic number and 6.941 as its atomic mass. So for lithium, what we're going to do is in our nucleus, we're going to have our 3 protons. And how many electrons, or how many neutrons? So this is going to round to 7. And then we have 7 minus 3, and we get 4 neutrons. Okay. Now if you think back to how many electrons we have, so if you look up at the top number, the number of protons is also the number of electrons. So we're going to put 2 electrons in the first ring and 1 in the second ring. Okay? So notice this right now is an unhappy or an unstable atom. Okay? I'm also going to draw an atom of chlorine. So let's look at chlorine. Chlorine has an atomic number of 17, and it has 35.45 as its mass number. Okay, so that means we have 17 protons. So I'll draw my nucleus with 17 protons. And if we do 35 minus 17, we'll get 18 neutrons. Now, if we're looking at this, you probably know that the number of electrons that we're going to need is 17. So as I draw this, my first shell is going to get my 2 electrons. My next shell is going to get my 8. Those are both full shells, so they are happy. I have a total of 10 electrons now. I need 7 more, so I'm going to make 1 more orbital and have 7 in here. But by putting 7 in here, we don't have our full 8. So this is not yet happy. But do you see here how this lithium has an extra electron to give? And this has space for 1 more? So what happens here is this electron from lithium is transferred over to the chlorine. So when we do that, we now have another electron here. Okay? And this one here is gone. So when we have that electron over there, this one is now happy, right? All of the orbitals are full. So I'll make a little smiley face here to remind us that this one's happy. And also this one's happy. Its outermost electron orbital is full. Okay, so let's erase this little movement line so you get the idea. And now that we have this, let's look at the charge on each of these atoms. So if we look at how many protons we have now, we still have 3 protons, right? If you remember, protons have a positive charge. Neutrons have a negative charge. Neutrons have a neutral charge, so they're not going to affect it. Electrons have a negative charge, and we have 2 electrons here. So if we look at the charges here, 3 and 2, the total charge, 3 positive, 2 negative, gives us positive 1. Okay, so we're looking at signs here. Positive 3 plus negative 2 gives us 1. So we have a plus 1 charge over here. If we look over here, let's look at this. The number of positive protons is 17. The number of neutrons that we have now is still 18. That's not going to affect us, but the number of electrons that are negative that we have is 18. And that's a negative. So if we have 17 plus a negative 18, we get a negative 1 as our total charge. So do you remember the idea that opposites attract? So here what's going to happen is we're going to have this lithium, which now has a positive 1 charge, and in chemistry we can just write that as a positive, and a chlorine, which has a negative charge, and what they do is they are drawn to each other. Okay? Because the positive attracts the negative. So here's my lithium, and here's my chlorine, and they're drawn together because of the charges that they have. And this makes lithium chloride, which we write this way, LiCl. Okay? I'd like us to look at another one today, and then we'll move on. So let's look at if we have beryllium and oxygen. So let's do the same thing there. We have beryllium and oxygen. If we look at beryllium, we have an atomic number of 4 and a mass number of 9.0122. For oxygen, we have an atomic number of 8 and a mass number of 15.99, right? If you look on your periodic table. So if we draw our beryllium, in our nucleus, we're going to have 4 protons. And we will have how many neutrons? Yeah, 5, because 9 minus 4 gives us 5 neutrons. There is space now for us to have our electrons. So remember, we have the same number of protons as we do electrons. So we're going to have 4 electrons going on the rings here. 2 are going to fit on the innermost shell. And then on the outer shell, we're just going to have 2. So this outer shell is not happy. Okay. Let's look at oxygen. So over here for oxygen, in the nucleus we have 8 protons because that's our atomic number. And neutrons, 15.99 rounds to 16. So 16 minus 8 gives me 8 neutrons that I have. I'm going to erase that mark. Since the protons and the neutrons, or protons and electrons, are equal, we're going to also have 8 electrons in this outer shell, or in the shell. So we're going to put 2 electrons in the first shell, and we're going to put 6 in the next shell, so that we have a total of 8 electrons around that atom. So now let's look at how these are doing. So if we look here, this one's not happy right now. So this one's unhappy currently because it only has 2 in the outer shell. The oxygen atom is also unhappy because it's missing 2 in the outer shell. It wants 2 more electrons in that shell. So you might get the idea here that now we're going to transfer these 2 electrons from the beryllium and send them to the oxygen over here so that our oxygen becomes happy. Okay, so now let me erase these so that we can see what it now looks like. So now we have, I'm going to write it in blue, the red marker didn't work so well. We have 2 electrons here. Now let's look at how these are. So at this point, these are ions because we don't have equal numbers of protons and electrons. Here, my beryllium now has 2 electrons in the inner shell. That makes it happy because this shell can only hold 2 electrons. Oxygen now has 8 electrons in its outer shell, so it too is happy. So now let's calculate the charge on each of these. So if we're looking at the charge on these, we're looking at how many protons there are and how many electrons there are. So protons, which are positive for beryllium, we have 4. So we have a positive 4 for beryllium, for the protons. Our electrons for beryllium, we have 2 negative electrons. So the overall charge is a positive 2. Okay. So when we write beryllium as an ion, we would put Be 2+. Now oxygen as an ion, because now the protons and the electrons are not equal, let's do that. So if we count up the protons, we still have 8 protons, so that's a positive 8. And if we count up the electrons, we have a negative 10. So positive 8 plus a negative 10 gives us, that's correct, negative 2. So our oxygen has a 2 negative charge. Now that these charges are equal and opposite, what happens is the positive charge here, 2 plus, and the negative 2 charge here makes them come together, just like magnets of opposite charge. So then we now have this compound that's called beryllium oxide. So let's look at our periodic table for a few minutes now. This whole process is interesting to see. It's not something I will expect you to be able to draw out, but hopefully it gives you a little bit of an understanding of how ions work and how ionic compounds are built. So let's look at your periodic table, because you don't really have to draw them for each element. What we can do is, for our main column elements, which are the ones you're going to be responsible for, there is a trend. These metals over here want to lose electrons, and the nonmetals like to gain electrons. So what we're going to do here is label what charge each group of ions tends to have. So for our group 1 here, these tend to form a charge of plus 1. The second column here tends to form a charge of plus 2. Let's start over here. I told you earlier the noble gases have no charge. They are happy how they are. This column here tends to have a -1 charge, the halogens. To the left of the halogens, the column that starts with oxygen tends to have a -2 charge. The column that starts with nitrogen tends to have a -3 charge. Now you'll notice there's a lot I did not put charges on. Those I will give you an ion table to help you figure out. Those ones, the charges vary, and sometimes there are more than one charge. So I will not expect you to know those ones. But I do hope that you'll start to notice that there are patterns with the periodic table and ions.